And so when we want to specify the IM3 level, we always need to specify it at a specific output power level. And as I showed you before, and we've gotten to this several times, we describe the intersection of these as the third intercept point. And it happens because these two intersect here. And I just want to emphasize, once again, we're calculating it from a power that's much lower than anything near the distortion. So we're ignoring any of the actual distortion. In fact, this intercept point could be higher than your 1 dB compression point. And this just has to do with the fact that it's an extrapolation from small signals. So we could talk about the input intercept point. And so this is just what input amplitude is this intersect point at. So that would be the IIP3. Or we could talk about the output intersect point, or the OIP3. Either one tell us about the same point. And the OIP3 is simply the IIP3 plus the gain. And that's just our definition of Pin plus G equals P out, right? That's all we're saying with that. And now we come to the final equation. You can calculate OIP3 from any given power, P1, right? And you use this formula, delta P, right? You multiply it by 0.5. And I'll just explain that once again. You put in a power, so typically somebody will say the IM3 equals minus 21 dBc. Well, IM3 is equal to delta P, P1, and as we said before, I've got to tell you where this is at. I can't just give you a number when P out equals 20 dBm. This is just an example. So P1 equals 20 dBm. So I've got P1, I've got delta P, here's my formula. Where did this 0.5 come from? That's why we went at length before to explain this. For every 1 dBm increase in Pn, delta P reduces by 2 dB. So what we do is we take delta P, we divide it by 2, and that tells us the delta Pn to get to the OIP3 point. Okay? Once again, just using the slopes and the geometries there. So here's the equation that you can use, but I always get confused about where does this 1/2 come from, and it comes from the fact that the difference changes by 2 dB per 1 dB of input, even though this is increasing by 3. The confusing part is this increases by 3, this increases by 1, and you need to realize that the differential increase is just 2 dB.